right? So the ratio of corresponding sides is called the scale factor. The polygons are similar if their perimeters are also similar, are also proportionate. So if the perimeters are proportionate, then they're similar polygons. And so let's just put this into action here. So you see these two figures. So it says, what's the scale factor of ABC to DEF? Well, we could just take one of these sides, ABC, and pick the corresponding side over here. See, that's this one. You see how it says A is equal to D and B, right, is equal to E, like that? So those are corresponding sides, 8 and 12. And so if we express that as a ratio, like this, 8 to 12, that's the scale factor. And of course, we're gonna reduce that. And when I say reduce, I mean we're gonna find the greatest common factor. The greatest common factor between 8 and 12 is 4. So then this would reduce down to 2/3. All right, so that's the scale factor. All right, so the scale factor going in the other direction, if we go from DEF to ABC and we wanted to express that as a ratio, we would just flip this upside down. That would be 12 to 8, or in other words, 3/2. And so, like I was telling you earlier, if they really truly are similar polygons, then their perimeters will also be similar. So if we add all these up, right, 21 and 15, that's 36, plus 12 is 48. And then if you look here, 14 and 10, that's 24, plus 8 is 32. If you were to express from DEF to ABC in that direction, we're saying 48 to 32, right? That's the relationship between the perimeters. Let's do it as a fraction. 48 divided by 32. What does that come out to when you reduce it? Okay, don't worry about that. It's 3/2.
Oh.
Right? Because what I'm telling you is, no matter what you do, no matter which set of sides that are corresponding, or even the perimeters, they always will have the same scale factor. Okay? If they're similar polygons. So now let me just solve a problem or two for you, and then I'll let you get back to work here. So number 3, what I'm going to do here is I'm going to show you two polygons that are similar, and I'm going to show you how we can prove that they're similar. So if I take the corresponding side, 12.5 and 10, see how these two angles correspond to these two angles? Okay, so 12.5 and 10 are related. Those are corresponding sides. If I put that as a ratio, 12.5 to 10, if I put that in my calculator, what I'm going to get is probably about 0.8. So let's put that in our calculator real quick and see what we get. There we go. Okay, I'm just going to record this, okay? All right, and then, so look at number 5. What we're told is that these two are similar. Here's the similarity statement right here. You see that? That's called the similarity statement. And so I'm told that AB, look at these numbers right here, or these letters, AB is corresponding to DE. So this side, X, corresponds to 25. So if I put those two corresponding numbers in the form of a ratio, this is going to give me my scale factor, right? And we said no matter which side we use, as long as we put two corresponding sides in a ratio, we're going to get the scale factor, right? So what I can do is go and pick another one of these sides. So I'm going to take BC 28. I'm going to put that on top, and then I'm going to go and find its corresponding side. So look up here, right? I'll do this in another color. So BC, that corresponds to EF, right? So EF is 20. So 28 to 20. I can set them equal because they're both equal to the scale factor, right? They are the scale factor. So now I'm just going to solve for x. To solve for x, it's really simple. All we're going to do, we're not going to cross multiply. A lot of people think we should, but I don't think it's simple. I think the simplest thing you can do is just multiply both sides by 25, right? So these 25s will cancel, and you're going to do this. X equals 28 divided by 20 times 25. All right, so the operation will be 28 divided by 20 times 25. So in your calculator, let's do that out. So 28 divided by 20 times 25, that comes out to 35. So x is 35. Does that make sense? Okay, let's do one more. So this value, x, I'm gonna put that on top. That's the bigger of the polygons. And then I'm gonna find its corresponding side. So SR corresponds to YZ. YZ is 32. So I'm gonna put 32 on the bottom. And then I'm gonna go and I'm gonna grab this other side that I know, 75. That's from the larger polygon. And I'm gonna go and find its corresponding side. So PS, let me do it in another color. PS corresponds to WZ. So WZ is 40. So that goes on the bottom. And then once again, I'm just gonna solve for x, right? To solve for x, I'm gonna multiply both sides by 32. These 32s will cancel. And so the operation is 75 divided by 40 times 32. So 75 divided by 40 times 32, that's 60. So x is 60.